Bismillah ar-Rahman ar-Rahim, chapter 26, uh, properties of light. We are going to cover, inshallah, electromagnetic waves, the electromagnetic spectrum, transparent materials, opaque materials, and the eye. Light is the only thing we can see in the electromagnetic spectrum. Electromagnetic spectrum. So we can say safely that a human being can see part of the electromagnetic spectrum, which is light. Originates, which is visible light, originates from accelerated motions of electrons, and it's an electromagnetic phenomena, as we said. Why we keep saying electromagnet? Electromagnet, so two parts, electricity and magnetism. So when we say كهرباء, كهرباء شو يعني كهرباء؟ كهرباء يعني it is the company responsible for كهرباء وماء. كهرباء وماء. Electromagnetic, that means there is an electrical field and there is a magnetic field at the same time. At the same time. Made up of vibrating electric and magnetic fields. As you can see in the photo, the red one is the magnetic field, which is changing as a sine or a cosine with a phase shift. And the magnetic field is the blue wave, which is perpendicular to the electrical field. So the magnetic field is always perpendicular to the electrical field, and this is the direction of wave travel from left to right. So of course the magnitude, the ratio, the magnitude of this photo, it's just exaggerated for the sake of illustration, because usually the magnitude of the magnetic field is about 1/1,000,000 of the magnitude of the electrical field, yani smaller by 1,000,000. But if it is, we cannot draw it smaller by 1,000,000. So just to show that both magnetic field, electrical field are perpendicular. If an electron vibrates up and down 1,000 times each second, it generates an electromagnetic wave with a period of 1,000, speed of 1,000 meters per second, wavelength of 1,000 meters, none of the above. It is none of the above. Of course, it is 1,000 hertz. It is 1,000 hertz. Electromagnetic spectrum classification of electromagnetic waves according to its frequency, their frequencies. Lowest frequency of light we can see appears red. That's the visible light. He is talking about the visible light. Highest frequency of light we can see appears violet. Higher frequency of light is ultraviolet, more energetic and causes sunburns. Beyond are X-ray and gamma ray. يعني let me try to enlarge this graph. So we start with a very long wavelength and a small, relatively small frequency. We start with the radio waves, then as a frequency increases, of course, the wavelength decrease. So we pass by the microwaves, and then we have the spectrum of infrared, اللي هي الأشعة تحت الحمراء. We have this tiny spectrum of the electromagnetic wave. It is the visible light. We start with red until violet, and then we have ultraviolet, and starting from ultraviolet, the electromagnetic waves start to have very high frequencies, which can affect living cells, cells. يعني starting from ultraviolet B and C, we can actually use them to sterilize things because it can kill living tissues, it can kill living cells. Ultraviolet, X-ray, and gamma ray. So at the top is gamma ray, very high frequency, very high, the highest frequency of the electromagnetic spectrum. The electromagnetic spectrum spans waves ranging from lowest to highest frequencies. The smallest portion of the electromagnetic spectrum is that the one with the visible light, as we said. Very small. We can see very small region in the electromagnetic wave. Which of these is fundamentally different from the others? Sound wave, light wave, radio wave, X-ray. Light wave, radio wave, X-ray are electromagnetic waves. Sound wave is the compression wave. So sound wave is different. Light is transmitted similarly to sound, يعني through a wave, we can say through a wave. Both are vibrations due to a vibration source. However, there is, as we explained before, there is a major difference between sound and light. Sound is a compression wave. It needs a medium to transfer. Light is an electromagnetic wave. It does not need any medium to be transferred, and it can go through air, liquid, and solid if it is transparent. Here he is trying to tell us one major idea. When light goes through a transparent material, he will explain in terms of photons, So basically, photons, when in a transparent material, photons will be absorbed by atoms and then ejected again, and then absorbed by the second atom and then ejected again, and then absorbed until it go out of the transparent material. So it's been absorbed and radiated or ejected. Absorbed and then ejected. So basically, if we start with one photon, we will end up with a another photon, it will have the same frequency, the same wavelength, but it is not that the same photon will go through the material. The photon will be absorbed and then ejected. Absorbed and then ejected. Absorbed and then ejected. يعني for example, suppose that you go into a mall and then you spend 1,000 riyal, and then somebody give you a gift, or you receive it through your salary, you receive 1,000 riyal. It is not the same 1,000 riyal that you spend. In terms of the same, يعني if you sign 500 riyal papers, notes, if you sign it just to make it different than the other 500 Qatar riyal notes, you will see that you will receive a completely different 500 Qatar riyal note. It's not the same one that you spend. So although you receive a 500 Qatar riyal, but it is not the exact note paper that you spent. It will have the same specifications, but it is a completely new bill. It's a completely new bill. Same thing of the light photons. When it enters a material, it will be absorbed, rejected, until it go outside the material. Oops. How light penetrates transparent materials such as glass? Electrons or molecules in the glass are forced into vibration. Energy is momentarily absorbed and vibrates the electrons in the glass. This vibrating electron either emit a photon or transfer the energy as heat. Time delay between absorption and re-emission of energy of vibrating electron result in a lower average speed of light through the transparent material. And indeed, light will go the fastest in vacuum. It will then become a little bit slower in the atmosphere. Then when it goes through liquid, it becomes slower, and through solid, if it is transparent, it will be even slower. Let's talk about glass itself. In glass, as you know, we can see red, up to violet. Through transparent glass. However, infrared will be reflected by the glass as a mirror, and ultraviolet will be absorbed through glass. So although glass is transparent from red until violet, if you shine on the glass infrared, it will be reflected. If you shine ultraviolet, it will be absorbed. طيب. From this information, we can understand now, for example, why in the summer, inside the car always hotter than outside the car. Well, the sun ray will go through the glass, heat up the car, and then any hot object will radiate infrared. So when that infrared wants to escape from the car, the glass of the car will just reflect the infrared. So then it will not let the car cool down. So that's the glass. It will reflect infrared. That's one. Two, you need to have some ultraviolet to help your body to build vitamin D. So you need to stay under the sun 5 minutes, 10 minutes every day. However, if you just close the window, the glass window, and you sit in the sun ray after the glass window, you will not receive a lot of ultraviolet. Most of the ultraviolet will be absorbed by the glass. So if you want to have ultraviolet light to help you to build vitamin D, then you should not have it through glass. You should have it direct sun ray. Average speed of light through different materials in vacuum, it's 300 million meter per second. Atmosphere slightly less than C, but we round it to C. In water, it's 0.75. In glass, it is 0.67, and in diamond, it's 0.41. So slowest in diamond. Strictly speaking, the photons of light incident on a glass are also the ones that travel through an exit to the other side, not the ones that travel through an exit the other side, absorbed and transform to thermal energy diffracted. It is B. It is B. Compared with the frequency of illuminating light on a sheet of transparent plastic, the frequency of light that is transmitted is slightly less, is the same, is slightly higher, depends on the type of the plastic. It is the same. It is the same. And that brings us, or that bring us to the fact that what we see is the frequency of light. We don't see the wavelength of light. We see the frequency of light. So the frequency of light when it enters the glass or a transparent sheet of plastic, the frequency will stay the same. The frequency will stay the same. The wavelength is different, but the frequency will stay the same inside the transparent material. طبعا we know the speed of light is equal frequency multiplied by lambda. Frequency of light, if transparent, always constant. طيب, what is different? When V goes down, lambda goes down. When V goes up, lambda will go up. But if the material is transparent, frequency is always constant, does not change. Does not change. So we see transparent, we say the light transparent before and after, so it will have the same wavelength. Also, when we shine, for example, red light in the water it go through the water, it will stay red, and it will go out the water also red. That means the frequency didn't change in the water. However, the speed of light changed in the water. That means lambda change in the water, but not the frequency. Not the frequency. The average speed of light is less in air before entering glass, in glass, air after emerging from glass, none of the above. The speed of light is less air before entering the glass. No, in the glass, in the glass. Oops. opaque materials اللي هي يعني المواد المعتمة التي لا تسمح للضوء بالمرور خلالها. Most things around us are opaque. They absorb light without re-emitting it. Books, desks, chairs, people are opaque. Vibrations given by light to their atoms and molecules are turned into random kinetic energy, يعني into internal energy. يعني those materials become slightly warmer. For metals, light shining on metal forces free electrons in the metal into vibration that emit their then they will emit their own light as reflection. وطبعا some يعني every metal has a slightly different color based on the vibration of electrons. The vibration of electrons of that metal. يعني gold will absorb all the light, and then it will make electrons to vibrate, and the electrons will vibrate the yellow wavelength. The yellow wavelength or the yellow frequency. In copper, they will vibrate red. In silver, they will vibrate something like gray. It depends on how, يعني gray, it's a combination of more than one wavelength, but it depends on how the electrons of that metal vibrate and what frequency they will absorb and what frequency they will reflect. You know that we see gold yellow because it will absorb all the wavelengths and then it will just reflect the yellow. It will just re-emit the yellow wavelength. Light incident on dry surfaces bounces directly to your eye. Wet surfaces bounces inside the transparent wet region, absorbing energy with each bounce and reaches your eye darker than from a dry surface. Now let's talk about shadows. What is a shadow? الظل يعني الظل. الشادو يعني الظل. Shadows, a thin beam of light, is often called a ray. When we stand in the sunlight, some of the light is stopped while other rays continue in a straight line path. We cast a shadow. a region where light rays do not reach. هذا الشادو الظل. Either a large faraway light source or a small nearby light source will produce a sharp shadow. A large nearby light source produces somewhat blurry shadows زي هون الثنتين زي هذول الثنتين. There is usually a dark part on the inside and a lighter part around the edge of the shadow. A total shadow is called umbra. A partial shadow is called penumbra. A penumbra appears where some of the light is blocked but where other light falls in, اللي هو الظل الجزئي. شوفوا هون هذه أمبرا، بينما لو شفتوا هون شوفوا هاي المنطقة اللي فيها الظل مش واضح كثير نسميها penumbra. هون he is trying to explain the solar eclipse and a lunar eclipse in terms of shadow. In the first situation, the shadow of Earth is completely far away from the moon, so we see a full moon. Here, the moon will just fall under the shadow of Earth completely, so we see a lunar eclipse. In this situation, the people here observes on the nighttime side of Earth are out of view of the new moon. اللي هم الناس اللي هون ما حيقدروا يشوفوا القمر. هون بيقدروا يشوفوا القمر، بيشوفوا فول مون الناس اللي هون، بس في هاي الحالة ما بيقدروا يشوفوا القمر. بتعرفوا احنا جايين على رمضان، كل عام وانتم بخير إن شاء الله، عاده الله علينا باليمن والبركات. لكن لو احنا في هاي الحالة ما حنشوف القمر. وهون اللي هو السولار اكليبس، انه هاي المنطقة من الارض، كبرها شوي، هاي المنطقة من الارض تقع في ظل القمر، فما بتشوف الشمس، يصير عندنا سولار اكليبس.